All right, so for this sixth one, we have that a modern art painting is contained in a square frame. Okay, perfect. The painting has a shaded region bounded by a smooth curve and a horizontal line. So this painting has, of course, what's already shaded, this. See? That's the shaded region. When the painting is placed on a coordinate axis such that the bottom left corner of the painting has coordinates -1, -1, and the top right corner has coordinates 2, 2. The curve can be modeled by blah blah blah. The horizontal line can be modeled by the x-axis. Distances are measured in meters. All right, so this paragraph right here, basically what it's telling you is that this line that I'm gonna put right now in green is your x-axis. See? And since this is -1, -1, that means my y-axis, again, this is very just, I'm kind of like highballing it. This would be like my y-axis, and my 0, 0 would be around there, okay? So that's all it's really uh, telling you, okay? So yeah, all right. For part A, use the trapezoidal rule. Damn, the trapezoidal rule with the values given in the following table to approximate the area of the shaded region. And then this is the table that they give us. See? All right, so we need to use trapezoidal rule with that. Now, I'm sure a lot of you are thinking, God damn it, I never fucking understood trapezoidal rule. It's so flippin' weird. Let me help you through it. Okay? And so, the trapezoidal rule in this case, we are using it to approximate the area of the shaded region. And so trapezoidal rule is very, very good for finding the area of a shaded region. And so why is it called the trapezoidal rule? Okay, it's called the trapezoidal rule because you can pick any sort of shape. In this case, it looks like the shaded region here. Okay, and what you're gonna do is that to find the area underneath that shape, you're gonna do a bunch of trapezoids. So I'm gonna make one trapezoid that goes like this, another one that goes like that, another one like this, another one like that. See? You're gonna add all of them up, okay? And that will be your approximate area. Now it's a little bit off, see? Why is it a little bit off? Because you're missing this, you're missing this, you're missing this. See? All right, how do you know like the coordinates of your trapezoids? Well, you know the coordinates of your trapezoids because they give them to you. Okay, keep talking, Mr. Giros Math. What the hell are you saying? So you have this point here, see? -1, comma 0.6, see? Because this is -1, 0.6. So if I go ahead and put that in, it would be here. This right here is -1, comma 0.6. Okay, what is the next one? 0, comma 1.2. So at 0, we have 0, comma 1.2. Ah, and here we have our first trapezoid. All right, where's our second one? 1, comma 1.2. So that's going to be, again, this is very much, I'm just highballing it. I'm going to put it here, okay? I would say that this is 1, comma 1.2. All right, so it's the same height, and it goes something like this. And then the last one is 2, comma 0. So here we have 2, comma 0. Bada bim, bada boom. So that would be 2, comma 0. All right, so those are my trapezoids. How many trapezoids are there? We have 1, 2, 3. And so I will find the approximate area of the shaded region by adding these 3 trapezoids. How do I do that? By using a fancy formula that is called the trapezoidal rule. All right, so that's the context of what we're going to do and why. Okay, it helps me find the area. You split up a curved, figure into more square-like figures. You find the area of those, add them up, boom. That's the trapezoidal area in a nutshell. Now, if we go ahead and open up our formula booklet, which I have right here, and you look for the trapezoidal rule, okay, it's right there. Now, before I go on, you, the day of the AB exam, will walk in with your brain, a very tired body, your pen, your calculator, and your formula booklet. Okay? Your formula booklet is one of the tools you can use that day. Okay? Get familiar with it. There's no use in knowing that the trapezoidal rule is here if you don't know what the heck this is even saying. Okay? And some of you probably didn't even know that the trapezoidal rule was in your formula booklet. Okay? So get familiar with it. Always use it when you study. It is an additional tool for the day of the test, and I would consider perhaps the most important one. All right, so the trapezoidal rule, what is it asking for? What is it? What the hell? So there's two parts to it, see? One part of it gives you the value of h, which is right here, okay? And then the rest you just kind of have to fill in, okay? So let's really try to understand what is going on here, all right? Some of these things you just have to sort of memorize, but I hope that I can help you understand better why, okay? Like why, what is going on behind the scenes, all that stuff, see? First of all, here is a sort of equal sign. See, when it's like this, it means approximate. Okay? And again, the trapezoidal rule helps you find the approximate area of the shaded region. It is not equal to the area of the shaded region. In fact, that is why in part B it says find the exact area. We're going to talk about that in a second. Okay, but just understand this is for finding the approximate area. That is why this symbol exists and why it's not equals. See? Second of all, you have integral of y dx. Okay, all that is really saying is that you're doing the integral of your function. Okay, which function is it? This line here, which is going to be my shaded area. Okay, that is what's going on. The integral is always going to be used for finding area. Then you have b on top and a on the bottom. Okay, following that intuition, b is your highest value vertically and a is your lowest value vertically. So, what is my highest value vertically here? 2. What is my lowest value vertically here? -1. And I know some of you might be thinking, shouldn't it be 1.2? Shouldn't it be, I don't know, 0? Yeah, you have a point. But the trapezoidal rule is kind of like, where are you picking it from? And then the trapezoids go in between, okay? I can't really explain it more intuitively than that. Your B and A values are going to be your biggest and your lowest uh, values on your graph, not necessarily your line. It's kind of like the area that you're scanning. All right, fuck it. I know that is kind of weird, okay? But B is going to be your highest Y value, okay? And this is going to be your lowest Y value, okay? And so we can actually already start filling in this a little bit. B, we said, was going to be 2. A was going to be -1. Okay? Cool. Then you have y d of x. See? And so y d of x is going to be, again, I said, your functions here to your line. And they tell us that the artist used the equation blah to draw the curve. So this is going to be my y. Here's a y equals. And I'm going to put a dx next to it because that's how integrals work. Okay? But my y is this whole thing. See? And so if y, which I'm putting in red now, is this whole thing, then I'm going to plug in that y over here. Okay, so y is -x cubed minus 3x squared plus 4x plus 12 divided by 10, and the dx is going to go right next to it, see? All right, so all of this approximate will be the stuff on the right, okay? The stuff on the right, so we start with 1/2, okay? So that means we're good here. And then we need to put h. Now, h we said was b minus a divided by n. Okay, we know that b is my highest y value, which is 2. We know that a is my lowest y value, which is -1. I divide this by n. Now, what is n? Let's take a moment, see? The rest of my formula talks about y0, yn, y1, y2, yn minus 1. And I know that looks really weird. Okay, so let me give you an intuition. The first two on the left side, y0 and yn, are going to be your first and last y values. Your first and last y values. That is why it's 0 for first and last for end. Okay? And on the other side, you're going to have all your other, quite literally, all your other y values. Okay? So, now that I put it like that, it's probably a lot easier to figure out. So if I go down here, and I tell you to focus on this table that's in green, ¿cierto? Which I now put in black, and I ask you, my fellow viewer, what is the lowest y value that you see here? Sorry, I asked that horribly. Let me try again. What is the first? What is the first and last y values that you see? Well, the first y value that you see is going to be this one, ¿cierto? It's the one that it's most on the left. So this is y0. Okay, what is your last one? Here. So that is yn. Everything in between is going to be your y1, y2, etc. See? Now this etc. that I just called this etc. See? This etc. is included only if you need to. See? So in this case, we actually only have y1 and y2. What do I mean by this? If this is y0, that means this is y1. That means this is y2. See? That also means, hint hint, that your yn is going to be y3. Because, you know, I'm just going in order. So this is y1, this is y2, that means this is y3. Okay, look at that. Hint, hint. This n, this 3, n equals 3. Ah, okay. Let's go back up here. So we have 2 minus minus 1 is 2 plus 1 divided by n we said was 3. 3 divided by 3, h equals 1. Okay, it's coming together, isn't it? See? Let's plug in h. So h we just said is 1. So I'm going to have 1/2 times 1. Parentheses y0, which we just said is 0.6, plus my last one, cierto, yn, which is going to be 0. So it's 0.6 plus 0, close parentheses. Plus 2 times all my other y values, which in this case is only y1 and y2. I don't have y3 or y4 in between. My y3 is my last one. I'm putting it here. See? Okay, cool. So, whoops. So it's plus 2 parentheses 1.2 and 1.2. Awesome. So 2 times 1.2 plus 1.2. Awesome. And so I plug in everything that's on the right, ¿cierto? So this would be the trapezoidal rule. I pop that into my calculator. Okay. 1/2. I don't really need to put times 1. I'm just doing it to show it. Parentheses 0.6 plus 0. I don't need to put plus 0 either. I'm just showing like that is yn. Okay. It's always good to be organized. Times 2, blah, 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 blah. Bada bim, bada boom. 2.7. All right. And that is for part A. Now, before I move on to part B, I just made a mistake. What is my mistake here? The answer is 2.7, but I'm halfway there. Aha, I need the units. What were the units in this case? Let's figure it out. Blah, 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 measured in meters. Okay, so this is meters. Meters what? To the power of 1, squared, cubed? Squared. Quick lesson. If you have units to the power of 1, it is going to be distance. If you have units to the power of 2, it is area. If you have units to the power of 3, you should know it by now, it's volume. Okay? In this case, we are talking about area. That's why it's squared, 2.7 meters squared. That is part A. Beautiful. All right, so now that we understand the trapezoidal rule, what's going on behind the scenes and all that good stuff, everything else just kind of flows. See? So part A finds the approximate area. See? We use the trapezoidal rule, we're good to go. For part B, we need to find the exact area of the shaded region. See? And so, for part B, they actually give us the equation that the artist used. See? And so for finding the exact area of a shaded area, the exact area of the shaded region, we need to use an integral. Okay? An integral is the one that looks like this. See? Where we had b and a, and we plugged into a negative 1. Okay, that's the one we're going to use now. See? So actually, what's going on is that this here that I put way earlier, this is exact value. This on the right side of it is the trapezoidal rule and is also approximate, okay? Approximate value. And so for the exact value, I need to do the stuff on the left, okay? Now I'm sure some of you are thinking, God dang, I gotta fucking do an integral of that? Dude, that is nasty. Like, I can't remember well how the teacher taught it, blah, blah, blah. All right, guys, I told you you're walking in with 5 tools, see? One of them I mentioned, make memory, is the calculator, okay? So pull out your trusty rusty calculator. I'm a boomer, so I got the TI-84, all right? But you can actually do this integral very quickly with your calculator. There is, because you walk in with a graphing calculator, you should be able to do this quickly. Okay, somewhere in your calculator, there's an integral button, okay? I'm just gonna call it your integral button. In this case, for the TI-84, you press alpha, window, and it pulls up this little menu. See? You can see that here in the menu, there's different tabs. You have fraction, function, matrix, y var. See? In this case, we're doing a function. Which function? The integral one. See? So we go look for it, and here it is. F of n integral. And actually, quick tip, but I'm pretty sure you can do derivatives here too with the third one. Yeah, you can do derivatives here too. But for now, I'm just going to show you the integral one, okay? Whoops. So, alpha, window, whoops, the fourth one, and there you have, integral. So what you need to do is up here, you put your b value, which we said was 2. Okay, I'm just going to follow what I have here, okay? I plug in 2. Down here, I plug in negative 1. Over here, I put my whole function, ¿cierto? Since it's a fraction, I'm going to do alpha y equals, pick the first one. Again, alpha y equals for fraction, pick the first one. And now it's a lot easier to plug in. So I'm just going to go ahead and put everything. Trust the process, it always works. Yada yada. Whoops. Bada bim, bada boom. D of my variable, in this case is x, d of x. So there I plugged in everything. I can go ahead and press enter. It calculates it for me, and my exact value is going to be, following the calculator, 2.925. I am missing something. Correct. The units. Squared. Why is it squared? Because we're talking about area. Boom. That is part B. Say no more. We move on. Part C. Find the area of the unshaded region in the painting. Ooh, god dang. Alright, that's a little bit weird, isn't it? So, what we did, again, context. See, what we did just now with the trapezoidal rule is that these figures I drew in red, we calculated that the area of this, from part A, ¿cierto? Is that it's, how much was it? 2.7, see? 2.7 meters squared. From part B, we found that the shaded area, ¿cierto? Which is like actually everything, the exact value, was 2.925. For part C, which they're asking for the area of the unshaded region, okay, we need to find everything that's in white, see? So, I don't really have like a white color, but I can tell you that we need to find the area of this and the area of this, see? Okay, so something convenient here is that because I have the area of the shaded region, I can just take the whole box and subtract what's here. See? So, what is the area of the whole box? Well, is it a box? Is it a rectangle? Aha, this is where context matters. Read again the problem. What did I highlight initially that I found important? It's a square frame. So a square, these values are all the same. Aha. Okay, so what is from here to here? Well, if this is -1 and this down here is 2, that means I have from here to here I reached the 0. Fuck it, I didn't explain myself very well. Point is, if the bottom left side of my square has -1 for my x, and the other side has a 2 for my x, that means I have 3 units here. See? Because if you make a number line and you go -1, 0, 1, and 2, how many times do you jump from -1 to reach 2? You jump 1, 2, 3 times. So that is why it's 3 units. So the side of my square is 3. And because it's a square, that means this is also 3. And so what is the area of a square? It's going to be base times height. I think that's in your formula booklet. Actually, that's probably not. Area of a blah blah blah. Yeah, area of a square is not here. Pero I do think it's very easy to memorize. It's just base times height. See, actually parallelogram. That is sort of like a square. So a equals base times height. Yeah, well, so the area of the whole thing, cierto? Area whole thing is 3 times 3, which is 9. So area of the whole thing is 9 meters. All right, cool. The exact area we found was 2.925. So if I go ahead and do 9 minus 2.925, it's going to give me the area of the unshaded region, which will be 6.08 meters squared. And if you want to put the exact value, it's going to give you 6.075. I was just doing significant figures up top. See, but either of these works. The essential part is identifying that it is a square frame and working from there, finding the distance of the square and finding the area. I hope that after this exercise you see that the trapezoidal rule is spooky, but it's really not that like fucked. You know, if you understand that this left side is first and last y values, and that the rest is everything else, and how to find n, I feel like you're good to go. Okay, so really get familiar with what's in your formula booklet. Understand the formulas. Don't just know that they're there. Okay, but yeah, that is for number 6.